Hello viewers, we have this beautiful equation to solve. It is a quadratic base and a quadratic exponent equals to 1. So what we have here today to solve is y squared minus 9y plus 19 to the power of y squared minus 3y plus 2 equals to 1. And to solve this, we are going to be considering the different cases under which the equation can hold true. And it also requires a good understanding of the law of exponents and power. So the first case we shall be considering. Now, the first case we shall be considering is from the law of exponents and power, where any base to the power of 0 gives unity, that is 1. So if we have, let's say a to the power of 0, it gives 1 from the law of exponents and powers, or what we could sometimes call the law of indices. So what does this mean for the equation that we have? What this simply means is that if the equation holds true, that is, if the left-hand side must be equal to the right-hand side, which is 1, then it simply means that the exponents y squared minus 3y plus 2 must be equal to 0. So that simply means that y squared minus 3y plus 2 must be equal to 0 for the equation to be true. And if this is so, we are going to factor the quadratic equation that we've got here by considering the factors of positive 2, factors of plus 2, whose sum will give us minus 3, the middle term. And these are minus 1 and minus 2. When added together, gives us minus 3. So our equation, the quadratic equation, can be expressed as y squared. Now, instead of the minus 3y, the middle term, we are going to be writing minus y, that is the first factor, minus 1. Then minus 2y, which is the second factor, plus 2. We equate that to 0. Then we do a kind of double grouping, these two and these two, and we factor. So from these two in our double grouping, we have y as the highest common factor, or the greatest common factor, which we take out. This will be y minus 1. Then from the second grouping, we can take out minus, can take out the negative sign, then 2 is also common. So having taken 2 out, or having taken negative 2 out, we have y left here. So we write that y, and this is going to be negative, having taken negative out. So the positive turns to negative, and we have 1 also with the 2 taken out, and that equates to 0. So from here, now we have succeeded in reducing the expression on the left hand side to 2 terms. Now y minus 1 in bracket is common to the 2 terms, so we factor it out as well. Then we have y minus 1, and when we factor that one out, we have y this and then minus 2, and that equals to 0. And if two numbers are multiplying, if a product is 0, then it simply means that it's either the first one is 0 or the second one is 0, or it could be that both of them are 0. So if y minus 1 is 0, then y could be 1, or y is 1, and if y minus 2 is 0, then y is 2. Now these are the two possible solutions in our first case scenario. Let's test another case. So the second case, we're going to consider the fact that in the laws of exponents and powers, when we have 1 to any power, then it must give 1. And what does this mean for the equation on our hands? It simply means that if it holds true that this to the exponent of this is 1, then definitely the base must be equal to 1, because when the base is 1, no matter the exponent, we always have it to be equal to 1. So what this simply means for us is that our base here, y squared minus 9y plus 19, can be 1. So if it is 1, we try to form a quadratic equation with 0 on the right hand side from it, and that simply means that we subtract 1 from both sides. So the 1 comes here and we subtract it from 19, leaving us with y squared minus 9y plus 18 equals to 0. Now, as usual, like we did during the first case, we are going to look for the factors of plus 18, whose sum will give us negative 9. So what are these factors? Factors of positive 18, whose sum will give negative 9. This, without wasting time, are negative 3 and negative 6, minus 3 and minus 6. So when added together, they sum to negative 9. So that the expression becomes y squared minus 3y, we use the factors now, minus 6y plus 18 equals to 0 on the right hand side. So we do double grouping as usual, which we do always whenever we have quadratic expressions that could factorize. Now from the first grouping, y can be taken out as the GCF to leave us with y minus 3. Then from the second, we could take negative out and 6 to give us y minus 3 as well. That equals to 0. And y minus 3 can be factored out, and we are left with y minus 6 equals to 0. So this simply means that y minus 3 could be 0, or y minus 6 could be 0. So if y minus 3 is 0, it follows that y is 3. And if y minus 6 is 0, follows that y is 6. So we have on our ends two more possible solutions, or two more solutions of the exponential equation with quadratic base and quadratic exponent that we are solving. Now, there is yet another case when it comes to the laws of exponents and power. And this other case, the third one, actually comes with a condition. So this, what we are considering here is the fact that when we have negative unity, negative 1 to a power, it will only be positive 1, given that if and only if the exponent, m in this case, is even. That's the only condition under which this will hold true. Now, what does this mean for our equation? What we simply do is we try to equate the base to negative 1. Then we try to solve the resulting quadratic equation from it. And after solving, we take one more step. And this step will be to test whatever we get from the equation, from the solution of the equation, the roots that we get. We try to test it. We try to test them. We test the roots in with the power, with the exponents of the original equation. So if after testing the roots, they give us an even value, then definitely this could also form part of the solution. They also could be solutions. So what this simply means is that we start with y squared minus 9y plus 19, and we equate that to negative 1. So with that done, we bring in the negative 1, which adds to 19. That is, we add 1 to both sides, so that our equation becomes y squared minus 9y plus 20 equals to 0. So we look for the factors of plus 20, whose sum will give minus 9. And these are minus 4 and minus 5. So the sum gives minus 9. Then our equation becomes y squared minus 4y minus 5y plus 20 equals to 0. So we group them in twos, or what we call double grouping, as we've been doing, and try to factor out what is common from the two groupings. Now, from where we are coming, we have y squared minus 4y minus 5y plus 20 equals to 0. And we have done the double grouping, so that from the first grouping, y can be factored out to leave us with y minus 4. Then negative 5 can be taken out from the second group, and after taking that out, we also have y minus 4, and that equals to 0. So y minus 4, that is common, will be factored out. We have y minus 4 and then y minus 5 to give us 0. So that if y minus 4 is 0 or y minus 5 is 0, then y equals to 4 could possibly be a solution, given that it satisfies the condition we stated earlier on. And also y equals to 5 could also be another solution, in addition to the 4 that we already had. Now, this third case doesn't end just here. We need to test the values, that is the 4 and 5, to see whether they satisfy the condition which we stated earlier on. That is, we put them in the exponent. The exponent is y squared minus 3y plus 2. That's the exponent. So we test when y is 4. That means the exponent becomes 4 squared minus 3 times 4 plus 2. And 4 squared is 16. 3 times 4 is 12, and then plus 2. So 16 minus 12 is 4, and 4 plus 2 is 6. 6, and this is even. It's an even number, and that simply means that y equals to 4 is another solution. We now have 5 solutions. So let's test the second value, y equals to 5. So we have when y is 5. We put it also in the exponent, giving us 5 squared minus 3 times 5 plus 2. And this is going to be 25 for 5 squared minus 15 plus 2. And 25 minus 15 is 10, whereas 10 plus 2 is 12. This is another even value of the exponent. So this simply shows that we now have 6 different solutions for the equation given to us. Now, the first term, if the set of solution, the equation, if S is the set of solution to the given equation, then S must be the set from case 1. We had 1 and 2. So 1, 2. From case 2, we had 3 and 6. And from case 3, we had 4 and 5. So the set of solutions are 1, 2, 3, 4, 5, and 6. 6 possible solutions. 6 solutions to the equation. The equation has 6 solutions. Thank you for watching the video. Hope you have learned something, especially about this equation. If you think there are other solutions that could come from this, you can let us know in the comment section below, or you can send us an email. The email handle is going to be in the description below. If you are yet to subscribe to our channel, please do so, and watch out for more interesting and educative mathematics solution even from us. Thank you for watching. Bye.